Now we have to think about how good is this slope as far as measuring the actual acceleration. And so to do that, we need to think about how many lines we could draw in between these points if it is constant. Right away, we do have some small error here, and that's because we have 0.1 centimeters. And if we look at our video, 0.1 centimeters is actually really, really small. So if we look up here, right now this is half a centimeter. If I shrink this down to well, let's see, there's 0.2. And you can see right here, 0.2 centimeter from here to there is a very small distance. And I don't know if I can say, maybe on this one, but now this side too, am I within 0.1? That means I'm pretty much on the dot, and it could be over here. And by the third tone here, it's like, yeah, it's really hard to say. I am a little more comfortable with 0.2. So if I go back to these values, I'm going to say 0.1 maybe with the first two, and then I'm going to put 0.2 in here and fill these ones down. And as we did that, you could see the error bars grow a little bit. All right, so if this is a straight line and we want to see what is the acceleration, we got to think about how many lines can we draw through these points and how steep and how shallow they can be. One tool to look at this, if you go to Insert under Illustrations and under Shapes, we can draw a line. And so this just kind of helps us. We know it starts at 0 because that's our initial velocity. And our line, we got to think how steep we can draw it through here. I usually like to make the line black. We can see a little better. And so now I can hold this point here and I can try to see how steep a line can I draw through all these points that still lies within all the points here. So right away I see I have trouble with this point up here and this guy down here. Let's make sure this is at 0. And so if I try to draw the steepest one, it looks like that's about as steep as I can draw. I can also draw another line here. And now let's draw the shallowest line we can draw. So I'll go from the same point here. And how far down, how shallow a slope can I draw that's still within, let's change this to black too. All right. And we can see how shallow can we draw. This point right here looks like our limiter. So I'm going to draw, looks like right to there. So these two lines represent the steepest and the shallowest slope I can draw through all these points and still be within their error bars. Now we need to find the slope of those points. They all start at 0, 0, and slopes rise over run, so this shouldn't be too bad. But I do need to find out where is my limiting points here. So we said that on the steepest slope, this one looked like a limiting point. If I hover over that point, it'll tell me. So this is at 241.857 and 0.808. So if I put these in here, let me get this out of the way. So I have my time and my velocity. And this is at 241 and 0.808, if I remember right. You gotta click on the graph and then hover over the point. Yeah, 0.8008 and 241.9. Well, I'll just round this up to 242 and 0.8008. All right. And so now I can find the slope of this here. So this will be my acceleration using those points. So it's rise over run, so the change in velocity over the change in time. So I'm going to say it's going to be equal to my velocity because it started from 0, went to 242 in 0.808 seconds. And that gives me 302. And that was my steepest slope. Oh, I'm careful. Not this point. I got to go to this point plus my error. So what is this? My error at these points was 0.5. So not 242. I'm sorry, my error for those points here was 29 points, almost 30. So I got to put 272 up here if I round a little bit. And that gives me 339.6. And that's more than the 328. In the same way, I got to do this here. I got to find the line that's making the least steep slope. And when we look through, I think we said it was this point right here was giving us the problems. So if we draw that here, when we just catch right there, and this point here is 0.634 and 222. So 0.634 and 222. But now remember here is 222 was the point, but now I got to subtract the error, and the error at 222 was right there. It was also 30. So I got to subtract 30, which would make this 192. And then when I find the same formulas, I get 302. So now my slopes here are 328 is my best acceleration, and my min's 302, and my max is 339. So if we think about what our error would be, we can go plus 11 and down 328 to 302 is down 26. So in this case here, we don't really have a symmetrical error. So we could say our final error here is going to be 328, and then we could say plus, we'd have to go up 11, minus 328 down to 302 is minus 26. And that gives me my final acceleration with error.